Dear students, welcome to the lecture series of engineering mechanics. In this video lecture, we are going to discuss about the topic dynamics of particles. We know that dynamics means movement of a particle or body in terms of the forces associated with the motion. Here, I introduce some of the important terminologies which are related to the motion of a particle or dynamics of a particle. They are distance traversed, displacement, speed, velocity and acceleration. First one is distance traversed. If a particle moves or tends to move, the position of a particle will not be seen after the time period t. Therefore, the change in position is known as distance as well as displacement. The only difference is the direction of a motion. If this does not consider the direction of a motion, then the distance or complete path traveled by a body or a particle is known as distance traversed, which means it's a scalar quantity. Again, in the case of displacement, it is the overall change in the position of a body, so that we consider here the change in the position as well as in the change in the direction also. For example, if we move a car by 25 km, in the sense it's a distance traversed by the car. If we travel 25 km in the north direction or in the south direction, it is known as displacement made by the car. Again, the next two parameters are speed and velocity of a particle or a body. Again, in the case of speed, it is a scalar quantity. On the other hand, velocity is the vector quantity, because the speed is known as the rate of change of distance traversed by the body. Again, in the case of velocity, it is called as rate of change of displacement in a particular direction. Again, we consider direction here, so that velocity is a vector quantity. Next terminology is acceleration. We know that acceleration is nothing but the rate of change of velocity. It may be positive or negative. If the velocity changes if velocity increases with time, it is known as positive velocity change and it is known as acceleration. Again, velocity decreases with the time, it is known as negative acceleration or retardation, or otherwise it is called as deceleration. Okay, the rate of change of velocity is acceleration, right? So here the rate of change of velocity is maybe uniform or maybe variable. If the rate change of velocity is uniform, it is the acceleration is known as uniform velocity, which means the velocity changes is in equal magnitude in equal intervals of time. If it is unequal, which may be called as variable acceleration. Next, we have to see about displacement, velocity and acceleration and the relationship between them. Consider a linear motion of a particle which is starting from point O, right, moving along the direction OX, because velocity is in a particular direction. Change of displacement, rate of change of displacement in a particular direction, so I consider the direction of OX with an uniform acceleration, right, with uniform acceleration. Let B be the position of the particle after the time period t. Let I say u is a initial velocity and v is a final velocity of a particle. T is a time period which taken by the particle to changes from changing the position of particle from O to P. Again, A is a uniform positive acceleration and S is a distance traveled in t seconds, which is the distance between O and P. Next, after t seconds, the velocity of a particle may be increased from u to v, because u is a initial velocity and v is a final velocity. Therefore, the total increase of velocity is equal to a multiplied by t, because after t seconds there is a uniform change in the velocity, so that the acceleration is change in velocity with respect to time, which is v by t. Here we need to know about the increase in the velocities. Therefore v is equal to a into t. Sorry, the increase in velocity is equal to a into t. Therefore v is equal to u plus at, because u is the initial velocity, a is the increase in velocity. This is the first equation of motion, and the average velocity is initial velocity plus final velocity divided by 2, mean of a initial and final velocity. We know that distance traveled by the particle s is equal to average velocity multiplied by time, because if it is increased in a uniform manner, for example, if the initial velocity of a particle is 0, there is no displacement takes place. Again, it is 1 meter per second. In a second, 1 meter of distance is displaced by the particle, traveled by the particle. Next, it may be increased by 2 meter per second, in the sense for 1 second 2 meter distance is traveled by the particle. If after 2 seconds the distance traveled by the particle is 3 seconds, therefore the initial velocity is 0 and final velocity is 2. The time period is again 2. From that we have to know about the s. Okay, s is equal to u plus v divided by 2 multiplied by t. Again, we know that from equation of motion, first equation of motion, v is equal to u plus at. We are substituting that into the equation number 2. S is equal to, we get s is equal to ut plus half at square. This is called as second equation of motion. Again, from equation number 1, which is v is equal to u plus at, we maybe find that t is equal to v minus u divided by a. Again, substituting this value into the second equation, which is s is equal to u plus v divided by 2 into t. S is equal to, we get 2as is equal to v square minus u square, or else v square is equal to u square plus 2as. This is called as third equation of motion. Again, we are going to see about some only one problem about the equations of motion. First example, a car starting from rest is accelerated at the rate of 0.4 meter per second. Find the distance covered by the car in 20 seconds and also find the final velocity of the car after 20 seconds. Here u is equal to 0 meter per second, because car is starting from the rest condition. The uniform acceleration is 0.4 meter per second square. Again, a is equal to 0.4 meters per second square. After the time period 20 seconds, we need to find out the distance covered by the car as well as the final velocity of the car. First equation of motion, v is equal to u plus at. Here we know u, which is from the rest condition, u is equal to 0 meter per second. Acceleration is 0.4 meter per second square and t is equal to 20 seconds. So we find that the final velocity of the car is equal to, after 20 seconds, is 8 meter per second. Again, from second equation of motion, s is equal to ut plus half at square, we find that, just formula substitution, we find that the distance traveled by the car is 80 meter. Right. Next, we move on to the relationship between displacement, velocity and variable acceleration. In the previous case, we find out the relationship between the displacement, velocity and variable uniform acceleration. Here we may find out the relationship by differentiation, or either by differentiation or by integration. If displacement function equation is given, we find it by the differentiation. If acceleration equation is given, we may find it by the integration. Okay, from this problem I have to explain how the relationship is found by the differentiation. A particle starting from rest condition moves in a straight line whose equation of motion, kindly note that whose equation of motion is given by s is equal to t cube minus 2t square plus 3. Find the velocity and acceleration after 5 seconds. We know that rate of change of displacement is velocity, rate of change of velocity is acceleration. From that relationship only we have to find out the velocity and acceleration of the particle. Here equation of displacement is s is equal to t cube minus 2t square plus 3. Here differentiating with respect to time period t, ds by dt, which is equal to 3t square minus 4t, which is known as velocity v. Again, if t is equal to 5 seconds, v is equal to 55 meter per second. Then again differentiating the velocity equation with respect to time, dv by dt is equal to 6t minus 4. I use that d square s by dt, which is also equal to a, acceleration. By substituting t is equal to 5 seconds, the acceleration is found as 26 meter per second. Again, I given another example from which we explain how the relationship is found by the integration. If the motion of the particle a is equal to t cube minus 3t square plus 5, where a is the acceleration in meter per second square and t is the time period in seconds, the velocity of a particle at t is equal to 1 second is 6.25 meter per second and the displacement is 8.8 meters. Calculate the displacement and velocity of the particle at t is equal to 2 seconds. Then here I rewrite the equation a is equal to t cube minus 3t square plus 5 as dv by dt is equal to d cube minus 3t square plus 5. We know that rate of change of velocity with respect to time is known as acceleration, right? I integrating this equation with respect to t, v is equal to t power 4 by 4 minus 3t cube by 3 plus 5t plus c1. c1 is the integration constant. Here I write v is equal to t power 4 by 4 minus t cube plus 5t plus c1. Again integrating the above equation with respect to time, integrating the velocity equation is given a displacement equation s is equal to t power 5 by 20 minus t power 4 by 4 plus 5t square by 2 plus c1t plus c2. We know that t is equal to 1 at t is equal to 1. Velocity is 6.25 meter per second and displacement is 8.8 meters. I substituting the values, I found c1 as 2 and c2 as 4.5. Here I substitute the values of c1 and c2 in the respective equations. At t is equal to 2, I put the t is equal to 2 value in the velocity equation. I found velocity as 8 meter per second. Again substituting the t is equal to 2 in the displacement equation, I found displacement as 16.1 meters. Next I move on to the laws of motion. First one is Newton's law of motion. There are 3 laws related to given by the Newton related to motion. We already know about Newton's 3 laws of motion. First law states that every body continues in its state of rest of uniform motion in a straight line unless it is acted upon a body by some external force. Here I explain about the Newton's first law of motion. An object is at rest. Here the football is under rest. An external force which is kicked by a football player changes the rest condition of a football, which is moved. The football is moved unless again an external force which is the goal net restrain the movement of a football. Again, second law of motion, the rate of change of momentum is directly proportional to the impressed force and it takes place in the same direction in which the force acts, which is F is equal to ma. Again Newton's third law of motion, to every action there is an equal and opposite reaction. Okay, here Newton's second law of motion is explained. if a cricket players try to catch a ball, it releases some momentum to his hand. Here we conclude F is equal to ma. Then if a person tries to get down, jump from the boat, if it is his action, the boat is again moved. It's created by a action of the person. As the Newton's law of motion may be clearly explained by firing a pistol, right? Next, as per Newton's second law, P is equal to ma. Then the above equation may be written as P minus ma is equal to 0. We know that it is and the first Newton's second law of equation is otherwise known as equation of dynamics. This equation is known as equation of statics or equation of dynamic equilibrium because it related to somewhat result